Hi guys, this is IGCSE O-Level Chemistry, paper 12, November 2013, question 1. An attempt was made to compress a gas and a solid using the apparatus shown. So we have a piston and we have a gas or a solid placed beneath the piston in the empty space. Which substance would be compressed and what is the reason for this? So the gas would be compressed, not the solid, because the solid would be occupying the complete space, but the gas molecules have spaces between them, so they can be compressed and the molecules can be brought closer together, and this would cause an increase in pressure and a decrease in volume. So this eliminates options C and D. Now, the reason why gas should be present. The gas particles are close together. No, the solid particles are close together, not the gas particles. The gas particles are far apart. Yes, that is why they can be compressed. Therefore, option B is the correct option for this question. Question 2. A student measures the rate of two reactions. In one reaction, there is a change in mass of the reactants during the reaction. In the second reaction, there is a change in temperature during the reaction. Which piece of apparatus would be essential in both experiments? So a balance could measure the change in mass, but not the change in temperature. A clock could measure the rate of change in mass and the rate of change in temperature. So time can be measured in both the cases. A pipette cannot measure any of these things, so it is not useful at all. And a thermometer will measure the change in temperature, but not the change in mass. So the only piece of apparatus that can be used in both the experiments in order to measure the time taken for the change in mass and the change in temperature to take place is a clock, making option B the correct option for this question. Question 3. Diagram 1 shows the paper chromatogram of substance X. So substance X was a mixture of substance Y and R. Diagram 2 shows the cooling curve for substance Y. So it cools to 147 degrees Celsius, then it stays at 147 for a long time, then it cools further. Okay, which statement about X and Y is correct? X is a mixture, yes, that's true. And Y is a pure substance because it cools to 147, stays there where it has a change of state, and then it goes to the lower temperatures. So staying at 147 for a long time shows that it is a pure substance. So this statement is correct. Next, X is a pure substance. No, X is a mixture. And Y is a mixture. No, both statements are incorrect. X and Y are mixtures. Y is not a mixture. X is a mixture. X and Y are pure substances. X is not a pure substance. Y is a pure substance. So this makes option A the correct option for this question. Question 4. Which statements about a sodium atom are correct? The number of protons and neutrons is the same. So the nucleon number is 23 and the proton number is 11. So 23 minus 11 gives us 12. So this is the proton number. This is the neutron number. They are not the same. So statement 1 is incorrect. 2. The number of protons and electrons is the same. Yes, it has got 11 protons and 11 electrons. So this is correct. The number of outer electrons is 1. Since sodium belongs to group 1, the number of outer electrons would be 1, making statement 3 correct as well. Since statements 2 and 3 are correct, option D is the correct option for this question. Question 5. The diagram show the electron arrangements in the atoms of 4 elements. Which element does not form a covalent bond? So in A, the outermost electron is 1, making this an element from group 1. And group 1 are metals. Metals do not form covalent bonds, they form ionic bonds. B is an element from group 4 because it has got 4 outer electrons, and group 4 elements form covalent bonds. C is an element from 2, 4, 6, and 7. Group 7, making this a halogen, and halogens form covalent as well as ionic bonds. And we've got 2, 4, 6, a group 6 element because there are 6 electrons in the outer shell. So this would make covalent and ionic bonds as well. So which element does not form a covalent bond? So group 4, 7, and 6 all form covalent bonds. Group 1 does not form covalent bond, making option A the correct option for this question. Question 6. Rubidium is in group 1 of the periodic table and bromine is in group 7. Rubidium reacts with bromine to form an ionic compound. So that would be Rb, Br. Rb would have a positive charge, Br would have a negative charge. Which row shows the electron change taking place for rubidium and the correct formula of the rubidium ion? So rubidium is a metal, so it will lose electrons and will form an Rb positive ion. So electrons gained is incorrect, electrons lost is correct, and Rb positive is correct, Rb negative is incorrect, making option C the correct option for this question. Question 7. Element X has 7 protons. Element Y has 8 more protons than X. So X would have a proton number of 7. Y would have a proton number of 7 plus 8 is 15. Okay, which statement about element Y is correct? Y has more electron shells than X. So for 7 protons, there would be 7 electrons. So the electronic configuration would be 2, 5. And for Y, the electronic configuration would be 2, 8, 5. So there are 2 electron shells in X and 3 electron shells in Y. So Y has more electron shells than X. This is correct. Next, Y has more electron in its outer shell than X. Okay, so we have the outer electrons as 5 in X and 5 in Y. So they are the same. So that makes statement in B incorrect. C, Y is a different group of periodic table from X. No, since the outer electrons are the same, both of them belong to the same group, which is group 5. And Y is the same, is in the same period of the periodic table as X. No, because the number of shells are different. X belongs to period 2 and Y belongs to period 3 as given by the number of electron shells present. So this statement becomes incorrect as well. Therefore, option A is the correct option for this question. Question 8. The formula of compounds W, X, and Y are shown. W is hydrated copper sulfate, X is hydrated magnesium sulfate, and Y is hydrated copper nitrate. Which statement is correct? W contains twice as many hydrogen atoms as oxygen atoms. So W contains 10 hydrogen, and the statement says W contains twice as many hydrogen as oxygen. So the number of oxygen are 5 plus 4, 9. So 9 oxygen. So this statement becomes incorrect. X contains the most oxygen atoms. So the most oxygen, so we'll count the total number of oxygen present. So this would be 4 plus 7. That makes 11 oxygen. And Y would contain 6 plus 6, 12 oxygen. So the greatest number of oxygen atoms are present in Y, not in X. So this statement is incorrect as well. Y contains the most hydrogen atoms. So now we count the hydrogens present. So in X, we've got 7 to the 14 hydrogen atoms. And in Y, we've got 6 to the 12, 12 hydrogen atoms. So the maximum hydrogen atoms are present in X, not in Y, making this statement incorrect as well. And lastly, we've got Y contains the same number of hydrogen and oxygen atoms. So Y has 12 hydrogen and 12 oxygen atoms present, making this statement correct. Therefore, option D is the correct option for this question. Question 9. A solid mixture contains an ionic salt X and a covalent organic compound Y. Two students suggest methods of separating the mixture as shown. So method 1 is shake with water, X plus Y, and then filter it. So X will dissolve in water and Y will not dissolve in water. So when you filter it, the residue is Y and the filtrate will contain soluble X. So this method seems correct. And in method 2, shake with ethanol. When we shake with ethanol, Y would dissolve and X will not dissolve. The organic compound will dissolve. So when we filter it, the residue would be X and the solution would contain Y dissolved in ethanol. So this method seems correct as well. So which method of separation are likely to work? Both should work. Both are okay because water will dissolve the ionic compound and not the organic compound, and ethanol will dissolve the organic compound and not the ionic compound. So both methods are correct, making option A the correct option for this question. Question 10. The diagram shows the circuit for electrolyzing lead to bromide and sodium chloride to liberate the metal. In what form are these salts electrolyzed for liberating the metal? So the metals liberated would be lead and sodium. So the only way in which we can get lead and sodium to be liberated would be if both of the electrolytes are in the molten state. Because if we would have concentrated solutions of either or dilute solutions, we would not get the metal being liberated, we would get hydrogen being liberated. So in order to get the metal, only the molten electrolyte can be used so that there is no presence of hydrogen in the electrolyte. So options are concentrated solution. This is incorrect. Molten is correct. And concentrated solution for sodium chloride is also incorrect. Molten is correct, making option D the correct option for this question.